Hi, and welcome to the DevSecOps. We are here to discuss how secure code, smart machines, and AI-driven can help on the cybersecurity. So today we have KINAITICS and LAZARUS. They are two innovative EU projects leveraging AI to defend against cyber attacks. KINAITICS enhance systems, robustness, and resilience by integrating AI with sensors and actuators, addressing the unique cybersecurity risks in interconnect cyber and physical systems. With in-depth research and innovative defense strategies, KINAITICS ensures the protection and resilience of those systems. LAZARUS, on the other hand, focus on securing the software development process by providing a comprehensive platform that addresses security and performance issues throughout the software development lifecycle. Using an intelligent sandbox powered by an advanced AI toolkit, LAZARUS detects, senses, and create patches for vulnerabilities, ensuring robust and secure coding practices. If you're a software development, an AI engineer, and anybody interested on cybersecurity sector, I think this is like the right event for you. And we are teaming, and you should team up with these projects, explore those innovations and network. I would say that you shall follow those professionals, and we're gonna use the chat for questions. You can put the questions in the chat, and so we can follow that. And for the presenter today, we have David Ariu, the CEO and co-founder of Pluribus One, and Konstantinos Patsakis is associated professors at the University of Piraeus and adjunct researchers at Athena Research Center. And me, Adriana, I'm director responsible for the research projects at APWG. We're gonna start today with David Ariu. He's, as I said before, he's the CEO and co-founder of Pluribus One. He got a PhD in electronics and computer engineer in 2010, and his master's degree in electronic engineering in 2006, both from the University of Cagliari. During his PhD, he has been visiting students in Georgia Tech Information Security Center, working with Professor Roberto Predeschi and Professor Winky Lee. He has always focused his research in machine learning applications of computer security, having published more than 25 papers in peer review, conferences, journals, and workshops. Over the years, he worked on network-based intrusion detection, malware detection, and passive DNS analysis. He regularly serves as a reviewer for international peer review, journals, and regular speakers during cybersecurity webinars organized by the Italian chapter of ESC2. He is responsible for coordinating the company participation in R&D projects. Over his career, he had participated in more than 10 R&D European projects. He operates as a senior cybersecurity consultant and several Pluribus One customers. Now I'm gonna address, put it like him to speak. Just a second. David, the floor is yours.
Okay, so thank you, Adriana. Thank you. Okay, so I think you should see my screen right now.
Yes.
And okay, so let's start then. So thank you, Adriana, and the Lazarus project for having myself as a representative of KINAITICS today in this very nice webinar. That's really a pleasure to share our experience here. So as you mentioned, in the next 10 to 15 minutes, I will be talking about the KINAITICS project, which is an EU-funded project that the Commission has funded under a call addressing practical implications of AI in cybersecurity, either on defensive and offensive purposes. And the flavor that we that we adopted and we went for as a consortium to address the topic was that of addressing systems that are kind of in the middle between cyber, so classical IT systems, and physical systems, because as you know, the boundary today is more and more, let's say, blurred. So just a couple of key facts about the project. It's a 36-month action, so we are going to close the second year of the project. We have 7 partners from Spain, Belgium, France, Italy, and Greece. The project is coordinated by CA, which is the as you know, the French agency for the nuclear energy that now is expanding a lot their areas of research and interest. I won't be able to share details into deep of the project because several of the topics and areas that we addressed are confidential, but I will have the chance to share with you the overall storytelling and the idea behind the project, and specifically one use case that where we as Pluribus are directly involved. As you know, as I mentioned before, the division of KINAITICS is addressing the topics and the implications of using AI in cybersecurity, either on the attack side, so to see how the threat landscape is expanding, which may be new threats, especially with respect to cyber physical systems, and of course also on the defense side, so how we can leverage AI to do more with respect to what we are doing right now. Consider that the project was written 3 years ago. So it was written before, for instance, the Mitre Atlas taxonomy of AI-driven attacks was published. It was first published in June 2021. And in the same weeks, we were submitting the proposal. And of course, it was written before the ChatGPT appearance on the market. That, of course, accelerated a lot. Everything is connected with the use of AI also in cybersecurity applications. Here in KINAITICS, the approach that we devised is focused around 4 key work packages. I'm not considering here all those that are related with communication and the management part of the project. But specifically, there is one work package which is entirely focusing on work package 3 on the offensive use of AI. Especially how we can leverage AI to attack cyber physical systems. And the other work package 4, is focusing on the defense strategies to be built in and incorporated within the systems. Altogether, provide the results and feed work package 5, which is that of system interaction and integration. And then we have a number of demonstrator and pilots that are run within work package 6. Here you see the list of areas that you are covering with the pilots and the demonstrator. There is one pilot which is addressing healthcare related issues, for instance, connected with image manipulation. There is a use case which is connected with web application firewall, into which I will dive deeply during the second part of the presentation. There are 2 use cases which are strictly connected with the development and implementation of cyber physical systems, there is one partner which focuses on the development of robots and machines and simulators that are used to, let's say, to respond to physical attacks like nuclear attacks or chemical attacks, and also systems that are using during the design of complex plants. So possible aspects that are connected with such design and implementation of the systems are addressed in the project. In our case, as Pluribus One, we focus on the use case connected with the web application firewalls that, you know, is a component that is used to monitor and protect web application and APIs from attacks that may arrive in the wild. And why this use case is relevant for KINAITICS, it is because, for instance, API are used as a layer of interconnection and to communicate by many physical systems nowadays. So they are a key point to monitor. You know, a web application firewall, which is a component, since the Lazarus project is focusing on DevSecOps, the web application firewall is focusing on the operation phase of the application and the services. So we are monitoring them once they are deployed and used by the customers and the services. And the web application firewall is a component which is deployed in front of the web application and services, and it's meant to stop the attacks targeting the application and the services. Of course, it cannot really patch the application. So if there is a vulnerability, the presence of a web application firewall cannot remove the vulnerability, but it may allow to mitigate the possibilities of exploitation. A web application firewall detection engine is made of two parts, basically. One is a component which is signature-based. So we have a set of rules, which are basically regular expressions that are able to identify well-known attacks, for instance, classical injection, local file inclusion attacks, or for instance, server-side request forgery attacks. In general, we are able to detect with signature-based components every attack which is known and for which we can specify and identify the malicious behavior by the means of a string, which is kind of codified within a regular expression. Diving more into details of this component, there are generally two parts. One is the engine, which is responsible for the applications of the rules on the traffic, and the second one is the set of rules that we can apply. Probably the core rule set by OWASP is the most popular set of rules, but there are also other set of rules by, for instance, Comodo or Atomic Corporation that are publicly available. What signatures cannot do is to model behavior of the clients and of the APs. And for that part, the web application firewalls typically leverage a machine learning or AI-based components. Why is this component more and more important? It is because we have, as you know, a very large part of internet traffic, which today is produced by bots. Almost 50% of the traffic is produced by bots, and of these 50%, we have about 20%, probably something more, which is made by bad bots. So they may be used to bring DDoS attacks. They may be used to scan for vulnerabilities or to scrape the website. The fact is that such bots are can be classified in 3 different levels because in consequence of the level of sophistication. The simplest bots are just scripts that you can run from the terminal. You have moderately sophisticated bots that kind of simulate the browser technology and also the capability to execute some piece of JavaScript code. And finally, you may have advanced bots that try to simulate the user behavior. And is in this part that AI and machine learning play a fundamental role, because you need to distinguish between behaviors that may sound or appear kind of legitimate, but that are implemented by a bot and not, let's say, do not belong to a human being. So what we are doing here in KINAITICS is to integrate into a software which is called Sandbox that we develop as pluribus one component, which is able to monitor the traffic incoming to the web application. For instance, connecting log files from the Apache or the Nginx web servers. It is able to control a firewall, for instance, a front-end firewall to block the bots, identifying, of course, the malicious behaviors. While developing the prototype, we are using a real traffic data baseline. So we are collecting traffic from production services, and so collecting traffic from real bots. We are on the defense side training a detection component, which is also robust against poisoning attack during the training, and is designed to be resilient against evasion attacks in the detection phase. There are different parts of this component. One specifically is based on the estimate of the rate of traffic that is produced by the bots. So it aims to limit the capability of the attacker to extract content from the website too quickly. And it's a component which is explainable by design. So identifying the key properties that an AI or machine learning algorithm shall satisfy. It is a component which is explainable by design. So it just estimates thresholds on the rate of traffic. So the principle behind it's really, really simple. In the plot that you have here in the slide, you see that we have different thresholds for different time windows. So basically what we do is to estimate the number of requests that are made by a client, by a legitimate client within a given time window. It is a component which is also robust because it is employing, of course, AI for defensive purposes and is trained on the whole traffic which is collected by the website. So especially in the case you have a large amount of traffic, statistics tend to be very, very robust. It is used and tested against offensive use of AI. For instance, one of the evaluation that we did is, of course, regarding the possibility for the client to evade the detection algorithm. And the experimental evaluation shows clearly that the algorithm forces the attacker to reduce the rate at which requests against the applications and the APIs are made. So of course you cannot stop at some point, at least thanks to this model, completely the attack, but you can slow it down and make the life harder for the attacker. And as I mentioned before, the system is also robust against attacks in the training phase. One evaluation that we did is about the residual detection capability once the 50% of the training data set is poisoned, which is a huge amount of traffic, especially if you consider a large an application or a service which is collecting a large amounts of traffic. And even in that case, we are left with a 50% detection capability. So the algorithm is very, very robust. So I will stop here and so pass the word to Costas for the Lazarus presentation. Of course, if there is any question, I will be really glad to take them during the final Q&A session. So Adriana, thank you.
Thank you, David. And again, you guys can put the questions in the chat, and we're gonna start them, like, you know, as soon as we finish with Costas. So right now we're gonna call Costas Patasakis. He is currently an associate professor at the University of Piraeus and an adjunct researcher at Athena Research and Innovation Center. His first degree was in mathematics from the University of Athens, Greece, and he has a master's degree in information security from the Royal Holloway University of London. He holds a PhD in cybersecurity from the University of Piraeus. His main area of research include cryptographic, security, privacy, and cybercrime. In the past, he has worked as research at the UNESCO Chair in Data Privacy at the Rovira and Virgil University in Spain, and at the Trinity College, Dublin, Ireland, and at the Luxembourg Institute of Science and Technology. No further ado, let me just check if there is anybody on the waiting room here. Just a second. I think we are clean. You did an amazing job taking care of that. I'm gonna give the floor to Costas. What happened with you here? Just a second. Costas, you can take the floor.
Thank you very much. Let me share my screen. Can you see it?
Yes.
Perfect. Okay. Many thanks for the introductions. I'm going to more or less describe the scope of our projects and its contributions. So the project is called Lazarus. It's funded by the Commission. Lazarus is a form of abbreviation for the Platform for Analysis and Resilient and Secure Software. So the problem that we're facing is that, as you can see here, the CVEs by year have been dramatically increased. The story is that if you set a milestone, you will see that probably something happened here during 2016 and 2017. And this is not the fact that developers started becoming a bit more less cautious on what they're writing on their code, but two things were introduced. It's the GDPR and the Presidential Policy Directive 41. So practically what happened is that on both sides of the Atlantic, we had the introduction of two new directives that demanded organizations to stop hiding under the carpet the vulnerabilities that they have and start reporting them. So this is why you see this explosion. The fact that you also have the vast digitization and the great increase in software use and development justifies why we have this this curve increasing so fast. So the question is, why do we need Lazarus? So practically, we are not talking about a new tool, but a new toolkit in order to adapt the existing software development pipelines. Practically, what we do is that we allow the user to pick and choose the tools that they deem appropriate for the existing pipelines, so that they can easily shift to what we call DevSecOps. DevSecOps is practically the extension of DevOps in order to include security. So most of the solutions currently are static, and this creates many issues regarding what they can detect. And practically most people and organizations will resolve to testing the solution when in terms of code, in terms of dependencies, and test it when it's running in terms of quality, but not in terms of security. The way that we have designed Lazarus is that we are the end user has the option to use the cloud or on premises. And one important aspect for us is to stress test the existing pipelines in order to find issues. So the project consists of 10 partners from 8 member states. It's coordinated by the Athena Research Center, and it started 2 years ago, almost 2 years ago. So the motivation, as I said, is to shift from the DevOps to DevSecOps. Some old threats still persist. The recent case of CrowdStrike and this nice blue screen of death that created a whole chaos showcases several things, like, for example, how poorly tested updates can lead to security issues, or the domino effects that these security issues have in terms of business continuity. Nevertheless, there are also new threats which require new needs, whether this is the case of the XZ utils that an APT actor tried to take over, actually managed to take over. It's a threat that took quite a lot of time in order to get the necessary permissions in the project in order to slowly deploy the backdoor. It shows that also, even if we are talking about machines, important aspect of the human in the loop and how it was tricked in order not only to allow people to join this repository, but also very importantly to let people bypass some tests that could reveal the existence of the backdoor. So practically this bypassed the existing pipelines. And moreover, since we're talking about code and the backdoor was implemented in the code, it shows the inefficiency of existing SaaS tools to detect such backdoors. So having this in mind, we try to prioritize what we should focus on. Lazarus, whether this has to do with security testing, the compliance with legal framework, the performing risk management and risk assessment, try to perform threat modeling and detect vulnerabilities in order to become more aware of the security exposure that an organization has. If you see it as a pyramid, you will see that Lazarus is built first in order to automate the vulnerability discovery, and then to realize DevSecOps. However, we have a part which is focused on the resilience and self-healing. So if there's a vulnerability, how we could not only detect the vulnerability, but also propose patches in order for the solution to be more secure. And as a result, this leads to NIS and GDPR compliance, and then the communication of these artifacts to the corresponding people and stakeholders so that they can have threat intelligence. We have 4 specific use cases that are going to test and validate the tools that we're building in the pipelines. One is focused on marketing technology, the other on enterprise software, the third one on media and publishing, and the fourth one on IoT technologies. So we're trying to practically cover as much as possible with the tools that we have in the pipelines. The market, we know that it's very segmented, but having quite diverse use cases is going to showcase better what we are doing and showcase that it's efficient. So what we want to do is that we're practically will run the executables in a sandbox in order to have some monitoring mechanisms that are going to allow us to detect whether, for example, something is wrong, and either go for self-healing or simply send a message to the DevSecOps team that something is wrong and that the proper patch should be deployed. The whole thing creates a trigger from to the repositories, which will allow the tools to execute and test what we have, or that what we have is compliant with not only the quality assurance that the project has, but it's also secure enough. If something is wrong, this is communicated to the information through the information sharing platform to Search and ISACs, so that they are aware that something is not working, and communicate the information to the proper stakeholders. So currently we have the alpha version. Nevertheless, the beta version is on the way. The typical user interface in order to interact with the platform has been created. We have an advanced secret scanning tool that it's able to collect information that it's left on code. We have a module which is scanning the software bills of material, some modules to detect SQL injection vulnerabilities, but also another tool that it's using AI and machine learning in order to detect vulnerabilities in the source code and propose patches. So the current interface looks like this, but this is more or less a depiction of the output of the corresponding tools. So I'm going to say a few words about the existing modules. So currently we have a tool which, as I said, is able to detect secrets on the source code. The issue is that many developers leave a lot of information on the source code, whether these are API keys or whether these are credential. Apart from detecting these strings on the code, we're able to understand the context. So we're able to understand whether these are database credentials, mail credentials, strings that are used in automation, or things that have to do with web services and keys that are used for collecting information from others. Of course, there's another a big category which is about others, so that we can provide the user not only with information that you left something in the code, but also understand the exposure that it has. So here, for example, is the output from the tool. So as you can see, we are creating a JSON, which is practically notifying the user where this information is. This information, this tool has been already integrated in the existing version. So as you can see, you will not deal with the JSON, but it's something that it's visually provided. Regarding the SBOM, the software bill of materials, we know that there are several vulnerability databases. Nevertheless, when it comes to scanning a solution, we must understand that there are many dependencies, and one has to have a good idea of what is their exposure. So practically in the alpha version, what we do is that we're trying to find the dependencies and that you have from the software bill of materials, and try to collect if there are some CVEs connected to these dependencies, so that you have a clear idea that if you use something, you will have security issues. So what you have is the score that is associated with this vulnerability, the description, so that you can understand the exposure that you will have, and the warnings and an ID of the vulnerability, so that each vulnerability is recorded individually. As I said before, there is another tool which has to do with the detection and patching of code vulnerabilities. So practically, we have two AI models which are going to detect vulnerabilities in the source code. The idea here is that apart from saying that something is bad, to also propose that how to handle it. So beyond saying that you have an issue in this line of code, we are also proposing some patches. To do so, we are using LLMs, and this is simplifying a lot the process, and it's quite robust for the time being. So this is more or less showcasing how this thing works as a pipeline. The benefits are quite clear because, for example, you have a very straightforward way of detecting vulnerable code and the corresponding patches. We're using state-of-the-art LLMs in order to do it. So the detection and accuracy are quite more advanced than typical tools that are simply using regular expressions in order to do that. And we have tried to make that to train the LLMs based on specific languages, so that the results are far more better than that you would have with other solutions. There is currently the beta version is almost around the corner. Apart from the code patching, we have a language detection tool. There are several issues with the detection rate of many tools if they don't find the proper the underlying programming language correctly. There is another tool which is doing the symbolic and binary execution in order to detect vulnerabilities. There's another tool which is trying to find vulnerability detection. It's performing vulnerability detection in source code, focused on the C language using LSTMs. We have another tool which is doing the security analysis of AI algorithms, and two specific modules, one about fuzzing and one about information sharing. That's all from my side.
Now,
Adriana?
yes, you can leave the screen on and we can
Yes.
start with question and answers. And thanks again for everybody that came. You can put your questions in the chat, and we can go one by one. And maybe to start with Costas, just because you were mentioning the end, maybe the feeling like, what do you think all this wave about AI and machine learning, again, you think is that a hype, or where you think all this came from?
Okay, so practically I can say that there's a lot of hype about machine learning and AI. Everyone is doing it, everyone claims to do it, and everyone claims to do it correctly and having astonishing results. I believe that as practice shows, nothing is perfect, and a lot of this is based on marketing needs in order to promote new products. Nevertheless, the truth is that currently, in terms of security, cybersecurity more specifically, we have a lot of data, and it's impossible to process everything, all these huge amounts. Currently, I can say that for sure that machine learning and AI can provide many good solutions, not only because they are quite accurate and because that they seem to do the work very well. The reason is that the data that we have is so really heterogeneous, and it's almost impossible to use traditional methods which are very, very static. We need to adapt, and in order to do that, you need intelligence. AI is the only way to make this shift. So it's not only the hype, it's the need. We need to make it work.
And David, what about your side? How you feel like for detection of the bots and the reaction on the bot-based attacks? Like how you feel in your side? Why AI?
Yeah. So for sure agree with Costas, with the things that Costas just said. So bot detection for the specific nature of the problem is a kind of attack or malicious behavior that we cannot detect by static mechanism, because again, in principle, there are cases where the behavior that the bot is implemented is not really malicious. So it is in principle something similar that a human being will do. Of course, everything changes if you consider that bots can do it at scale, and behind those there is somebody that is using that information which is maybe scrapped on collected by bots on some third parties website. In that case, signatures or static mechanisms cannot do anything, because there is not a specific vulnerability which is being exploited. So the only thing you can do is try to analyze the behavior of the clients to detect the undesired ones. And the only way you can do it is by using some kind of machine learning. And so do not forget, we have not to forget, just to add one point on what Costas was saying, is that not only machine learning can be used, or AI more in general, can be used during the detection phase, but also can be an enabler for the static detection mechanism. So for instance, the classical signatures that we can use to spot specific attack categories can be generated and are typically generated with the support of machine learning or AI. So indeed, given the amount of data we have so far, machine learning and AI play a fundamental role in cybersecurity.
Thank you, David. And Costas, how you are measuring the effectiveness of the AI machine learning tools that we are using in Lazarus?
So I believe that currently one of the important issues that we have with machine learning and AI is that we're trying to test everything in a very nice defined comfort zone, forgetting that when you put a solution out, it will not be like that. We have a publication that's going to be available mid-September, where we try to push several AI solutions in terms of vulnerability detection to their limits, trying to put them out of their comfort zone. What you will see is that when you simply try to change the dataset that they are working on, everything is practically destroyed, and you will see that the detection rates fall to the point that you will say that if it finds something, it's random. To this end, what we try to do is that we try to create the diverse data sets, try to be as pragmatic as possible and expose our solutions to real-world scenarios, so that we can have the best, let's say, adoption of real-world cases to the training. If we say that in my lab something works, it's practically a lie, because you try to push under the carpet the fact that it works in the lab, so it doesn't work in the real world. So this is something that we try to remove from our testing by having as much as possible different data sets, try to test it with strong, let's say, criteria, and beyond the comfort zone that someone would have.
Thank you. Now, please, if you guys, anybody that is attending have any questions, just put on the chat and we add it on. I have one more question to David. What do you think might be the challenges connected with the AI supply chains and how you plan to address that?
Okay, yeah. So that's an interesting question because as Kostas was mentioning before, everybody now in every business context is trying to use AI, or at least is claiming to use it. In many cases, this is not done because, for instance, in the case of the LLMs, there is a clear, let's say, issue with the costs. In many cases, people are doing it by leveraging third-party components that may be either pre-trained models, it may be services like those that all the big players of the cloud are making available right now. And of course, we are not really aware of the degree of the security which is connected with such solutions. Many issues, as typically happens, are identified and discovered only once systems are entering the production phase. Consider that the LLM revolution, as I will call it, it has just started less than 18 months ago. And I think it's a time window not large enough to have deeply analyzed and identified all the possible issues. So it's that of the AI supply chains, a topic we should be paying attention to in the next years. Also considering the fact that differently from what happens for code security related issues, for which we have several tools like those that have been described during the Lazarus presentation. In the case of AI, automatic testing at scale of the algorithm is not possible. And so we are still in a, let's say, initial phase of the discovery of the issue, even if many issues have been already identified. I think, for instance, in the case of the LLM, to the OWASP top 10, which applies to the LLMs. But again, it's a topic to pay particular attention to before bringing AI into our processes and solutions. So that's my point of view.
Okay, thank you. We only have 1 more minute. I don't know if you both, like, we can talk about AI Act or anybody, any of those things, but like maybe if you guys can just wrap it up, to do a phrase on wrapping it up on how is the better way to contact you guys and all that. I left a link for our newsletter and it's also on the QR code. But David, I can leave the floor to you and to Kostas, and so you guys can just wrap the event.
Okay, yeah. So just one sentence about the AI Act. The AI Act is an act on AI systems, which brings together AI security and system security. So to secure AI, we need to secure the system. So the training and the protection of the data set is a very typical case. So we have not to forget the classical cybersecurity measures. So well, thank you again for the opportunity. People, if you're interested, can find me easily on LinkedIn. Just type my name there, and I think you can easily find me there. So
thank you.
Thank you.
Kostas, last words.
So I will simply try to avoid the discussion because of time constraints. The only thing that I can say is that we have a new domain which is emerging. It's not cybersecurity, it's not AI, it's something in between. And when you have people from each side trying to be on this intersection, is not so easy because you have many issues understanding the concept from each side. That's my only comment. In terms of reaching out, you can use either LinkedIn, emails, try to use our forms in order to register our stakeholders, and we will be in touch with you.
For sure. And thanks a lot. And I hope everyone has a nice day today. Thank you. Bye-bye.
Thank you.
Thank you very much. Bye.
Bye.